Hello guys, this is Asharam and today I'll discuss longest palindromic subsequence. So you're given a string S and its length is n and you have to find the length of longest palindromic subsequence. So first of all, what is a palindrome? So suppose you are given a string, let's say A B B A, and so first character from beginning and first character from end is equal. Second character from beginning and second character from end is equal. So this is a palindrome. So generally, if si from beginning, ith character from beginning is equal to si from end, ith character from end, then that string is a palindrome. So if we want any other example, so also a b CXCBC is a palindrome. Sorry, this okay, because they are equal, and this is obviously equal. S4 from end from begin equal to S from end. Okay, so now you are given a string S and you have to find the length of longest palindromic subsequence. So let's say the string is A B C D and C B A F. So you can clearly see that this whole thing is a palindrome. This whole thing is a palindrome. So its length is 7. So our algorithm should return 7. And if you want to take another example, then this A S A N A S, let's insert some characters here, X Y Z. Okay, so you can see that this and this, wait, let me use another pen, and this A and this A. So in the string, this is a palindrome of length 5. Okay, of length 5. Note that in place of a you can also use Y. So this is also a palindrome of length 5. So we have to find the length of longest palindrome. Okay, so now, as I've told you in last videos, that you have to find the recursive solution first, the brute force solution, because we can optimize brute force solution, and if we are not able to optimize it, then we can look for another approach. So let's try our first step, that is find the brute force solution. So brute force solution is simply checking all the subsequence and then finding the length of longest palindrome. Okay, so let's say I will check it. So let's say you have a string S and its indexes are 1, 2, 3, 4 until n minus 1 and n. So now you want to find the length of longest palindromic subsequence within length 1 and n. So now consider the last two characters. Now if they are equal, then they will definitely be a part of our longest palindrome. Okay, because if we don't include, let's say, Sn in our palindrome, and suppose there is no other character equal to, means all other character are not equal to each other, means this whole 1 till n minus 1 is 1 are distinct characters. In that case, there will be a palindrome of length 1 only. So we are missing our length, palindrome length of 2. Okay, so it should be 2 plus, because we are including two characters, first and last characters in our palindrome. Then we have to find the length of longest palindromic subsequence in this string. So it will be 2 plus LPS of 2 comma n minus 1. And now what if this is not equal, if s1 is not equal to sn? In that case you have two choices. Either you don't include this nth character and you check for the length of longest palindrome in this string, okay, or another choice is you exclude this one first character and you check for the length of longest palindrome in this subsequence, sorry, this string. Okay, so if first string returns some length, let's say x, and second return, let's say some y, and since we want our palindrome to be maximum, so we'll take maximum of x and y. So if s1 is not equal to sn, in that case we should return maximum of lps 1 comma n minus 1 for first string and lps of 2 comma n for second string. So we can extend this idea to a general relation. Suppose that you have a string whose beginning character is I and end character is j. In that case, if si equal to sj, if si equal to sj, then we should return 2 plus lps of 2 comma n minus, sorry, this should be, let me erase that way. So it should be lps of I plus 1 comma j minus 1, because we are including si and asj characters in our subsequence, and then we just have to check in the reduced string, that is I comma j. So the reduced string will be I plus 1 until j minus 1, and otherwise we have to return maximum of lps of, in the first string which is possible, j minus 1, and second string which is possible is I plus 1 comma j, otherwise. Okay, so yeah, this is the recursive relation, but this relation is still incomplete because we haven't given any base cases to it. Okay, so definitely if I is greater than, if I is greater than 0, greater than j. Okay, so if I is greater than j, then there is no string possible, so length of longest palindrome will be 0. Now suppose we are at string I. Okay, wait, if let's say I and j are equal, I equal to j are equal, then a string of length 1 is always a palindrome of length 1, so we'll return 1. And let's say there is a third case, let's say I and j are consecutive, that is j equal to I plus 1, and if they are equal, that is si equal to sj, then it will be a palindrome of length 2. So if j equal to I plus 1 and sj equal to si, then we should return length 2. So our recursive relation is complete. So this is our recursive relation, and this is also our brute force solution for this problem. So this solution is O to the part O of 2 to the power n. Okay, let's see how. So suppose you are currently at, wait, let me choose another pen. So you are at LPS 1 comma n. Okay, now in the worst case what you can do means 1 and n are not equal, so you'll do NPS 2 comma n or LPS of 1 comma n minus 1, because we have to find length of longest palindromic subsequence within 1 and n, so we'll call our function by this. Okay, with these arguments. So we have these two choices. Okay, now in the worst case again we will have two choices. So on we can have choices again and again till this n. In first step it will become n minus 1, in second step it will become n minus 2, and we will again have two choices until 1. So height of this tree will be 1. This tree will unfold in n steps. First step is this, second, third, fourth, until this become 1 and this here become n. Okay, and in each step you can see that the number of sub problems will be multiplied by 2. So in first there were only 2, sorry, in first there was only 1, in second there was only 2, and in third there were 4. So in the end we'll have 2 to the power n. So total number of sub problems will be definitely be greater than 2 to the power n. You can also find the exact number of sub problems, but we are not getting into the mathematical details here. So total number of sub problems will be greater than 2 to the power n. So the time complexity of our algorithm will be, time complexity of our algorithm is O of 2 to the power n. And you know, this is the worst time complexity we can get. Okay, worst time complexity is n factorial, but even this is not good. Okay, so let's see what we can do. So let's say you are trying to run LPS of 1 to 5 in worst case. Okay, so you'll run 1 comma 4, you'll run 2 comma 5, then you'll run 2 comma 4, or you'll run 1 comma 3. Similarly you'll run 2 comma 4, or you will run 3 comma 5. So now you can see that this problem here, this problem here are same. That is, there is this overlapping of sub problems. We are repeating same problems, we are solving same problems again and again, and that is why the number of sub problems is greater than 2 to the power n. This is the reason, because you can see that in LPS I comma j, I can have maximum value n. I will take values from 1 to n, j will take values from 1 to n. So maximum number of function calls you can make is n into n, that is n square. That is, we just have to compute only n square sub problems, but we are computing 2 to the power n sub problems. So we'll use dynamic programming to optimize our solution. So as I have told you in previous videos, our standard method to convert a recursive solution to dynamic programming solution. So what we'll do is, we'll add a check here. We'll add a check in this step. Let's see what will check. Okay, we'll declare an array. We'll declare an array of size n and n, and we'll say that if problem is already calculated, if problem is already solved or calculated, already solved, then we'll return our dpij. And okay, because we have stored the solution in our this array. Okay, and now if problem is not solved, then we'll solve using these two conditions, and whatever the answer we get, we'll assign that answer to dpij equal to whatever the answer we get. So in this case, we can optimize our solution to on square time and on square space complexity. So yeah, so our algorithm is over. So now we have to write code for this algorithm. So we'll open Sublime Text now. So Sublime Text. So I've already defined the maximum size of our the string, that is 1001. Okay, so let's say you have a string s, and also its length is, let's say, n, and we'll have our dp array of size max and max. Now we'll create our lps function, lps, and it will int I int j. Now if what I greater than j, return 0, and if I equal to j, then return 1, and if I equal to j minus 1 or j equal to I plus 1 and si equal to sj, in that case return 2. Also you can also assign it to dpij. So we are assigning it to dpij, both of them. Now we have two cases. If si equal to sj, so we are following one based indexing. Okay, we can also follow zero based indexing, there is no problem in that. Okay, so remember that we are following zero based indexing in this code. So instead of 1 comma n, we'll run our function from 0 to n minus 1. So if si equal to sj, then we'll simply return and assign dpij to 2 plus lps I plus 1 comma j minus 1. And in other case, we'll return and assign dpij equal to what, maximum of lps I plus 1 first string, and then we'll have our second string. And yeah, so this is it, I think. Okay, so let's assign some string s equal to abc a b a x and c out what, lps. Okay, we have already defined it globally, so we no need to define it here. And also let's say n is 3, n is length, s dot length. So we'll return 0 comma n minus 1 and end. So yeah, that should work fine. So let's copy it and paste it in IDE 1. So we'll copy it. So this is our IDE 1. So we'll write new code. So let me zoom in it, okay, for you. So we'll choose C++ 14, and then we'll paste it, and then we'll run it. So let's see, I think it should work. So it's running. So you can see we got length 5. So length, our maximum length possible is what what should be the possible maximum length? So you can have ABC, you can have, wait, okay, let me write. Okay, you can have ABCB and A. Okay, ABCB and this A. The length of longest palindrome will be 5. So that's it guys for today. I think you would have enjoyed this tutorial, and if you liked it, then don't forget to subscribe to my channel and follow my blog. Okay, so yeah, thank you.